My name's Neal. I'm from SciBite. I'm the head of technical sales here. Who are SciBite? We're a semantic technologies company working in the life science domain. Our customers include most of the top 20 pharma and many of the kind of smaller tail end groups working in life sciences. We also work with agroscience, consumer packaged goods, anybody who's doing kind of biological research. Nearly every meeting I go to, we get talked about this. Machine learning, AI, these are the buzzwords that all the senior people talk about. And the elephant in the room is actually the quality of the data. It's pretty well known at the scientist level and the people doing the actual work that if you've got poor quality data, you can't expect great quality results on the way out. We're at the mercy of the quality of the data. The Harvard Business Review publishes numerous, probably every 6 months or so, a new article on this. And this is what we're faced with a lot of the customers. And our mantra at SciBite is to generate clean data, but how do we do it and what's important? There's a growing movement that hopefully many, maybe all of you have heard about, which is the FAIR movement, which is making data more accessible, more findable, reusable, interoperable. Maybe I should have said those the right way around. There was a PwC report last year that calculated the cost to industry of not having data that is easy to use, and that was over 10.2 billion in Europe alone. So, this is a really, really cost prohibitive thing by having poor quality data. And that's where SciBite fit in. This is the kind of message that we have. We help our customers achieve and create clean data by combining world-class ontologies, and we build, augment and enrich public ontologies. Our customers use their own ontologies, or we just use vanilla ontologies from the public domain. It really depends on what the customer wants. We combine those with various algorithms and approaches to transform unstructured text. So we find all the scientific entities in text, whether they're genes and diseases and phenotypes, chemicals, compounds, structures, and things like that. And for every single concept, we have what's called a vocabulary. I can't fit them all on the page, but we've got about over 100. And here's some of the ones that you can see. And we group them by sort of use cases, so clinical, biological, agroscience, biopharmaceutical, production, and so on. We have a curation team at SciBite that specialise in optimising vocabularies for entity extraction. So just because you've got a term and a hierarchy doesn't mean it accommodates for how they're represented in free text, because someone could have spelt it wrong or used a different synonym or an acronym that you've not seen before. And we have a curation team that build and optimise these vocabularies so they find all these terms in unstructured text. We always, wherever possible, align these to public ontologies because we don't want to tie people into proprietary ontology. It kind of defeats the point. So whenever we index data, we find these public URIs to make the data more integratable. We're agnostic to the data coming in, and we're agnostic to the platforms they're used on the way out. So Ontoforce, just before, one of our partners, as a platform where you can load the data in there. IDBS are a partner of ours. They're looking to integrate data into their ELNs, and there's a long list of these. The point here, actually my head's in the way, is rather than do chemistry ourselves, we thought we'd use ChemAxon, right? These are the guys and the girls that know what they're talking about in chemistry. So rather than reinvent the wheel, let's take the best in class in transforming images to structures, and structures to public IDs, and compounds to IDs. So one of our vocabularies is literally the ChemAxon entity naming capabilities they have. And here's just a quick picture of one of the UIs that we have just to demonstrate how this works. So free text boxed in black, you type in your terms, and our tooling basically indexes and shows you the entity here on the right-hand side. This is all down and on a RESTful architecture, so it's built to be integrated into existing architectures. So whether you've got a SharePoint search site, whether you've got a master data management system, whether you want to manage ontologies, whether you do enterprise search with Sinica or some other tooling, they all require clean quality data, and our architecture is embedded in there to transform all the text, the patents, the publications, the ELN data, and all these different sources, creating these terms and indexes that align to public ontologies, and these all then feed into the system to provide better quality results. I'm not going to go through this entire slide, you'll be happy to know, but we cover lots of different use cases across the life science domain, from master data management about building, managing, centralizing, and distributing ontologies across a business, to about data entry or data capture from ELNs and LIMS systems. We can integrate within the architecture if the partner wants to do the integration, and we can index on the external as you load into a third-party tool if you wanted to do it that way. Once you've actually generated the data, then you've got in the middle the kind of search pieces about finding things, sharing things across the enterprise. Building on that, then you've got kind of monitoring, so whether it's pharmacovigilance, horizon scanning, drug repositioning, things like that. And finally, a lot more of the more knowledge-based activities at the moment, building knowledge graphs and looking for these kind of cool assertions that are linked between different sources of data. They all require clean data to start with, and that's ultimately what we do at SciBite. So I'm Neal. You'll find me with a SciBite t-shirt on. If you want to chat to myself or Jules, the head of sales, we're over here today only. We're heading back today, but thanks for your time.